Hello everybody, it's Arthur Science and welcome to my first long video on the laws of motion. Before starting, don't forget to subscribe and activate the bell. Let's start with a logical question. Who wrote these laws? It's of course Isaac Newton, who is a very famous English scientist of the 17th and 18th centuries. He has worked in many scientific fields like physics, mathematics, optics, or even astronomy. One of the most important things he did is his book called The Principia. The book was published in 1687. The book is divided into three main parts and totals about 500 pages. In the book, Newton talks about many things, but for today we will focus on the laws of motion, which are in the first main part. So Isaac Newton's first law explained that if no force acts on an object, its motion remains constant. This means that if an object is stationary, it remains stationary, and if it is moving, it continues to move straight ahead at the same speed. For the object to stop, accelerate, or change direction, a force must act upon it, such as a push or a brake. This principle is called the principle of inertia. Now let's see three examples to understand. In this first example, the ball doesn't move until someone hits it. Gravity pulls it downward, but the ground prevents it falling any further. The forces are in equilibrium and the object remains stationary. Second example, someone hits the ball, which then starts to move in a direction because the balance of forces is broken. The impact of the hit applies a force that makes the ball accelerate, as long as the foot remains in contact with it. In this last example, the ball slows down due to air resistance and ground friction, and stops because of the foot. This means that a force is needed to stop the movement. When it is at standstill, the forces are once again in equilibrium. The second law of motion, dynamics, states that when a force is applied to an object, the object will accelerate in the direction of the force. The larger an object is, the more force is required to make it accelerate. Let's see two examples. When you throw an apple, the force you impact to it makes it accelerate. Acceleration is the way in which speed changes over time. In this second example, imagine that the mass of this watermelon is the double of the apple, and that will use the same force, so the acceleration will be half of the apple. Newton's third law, also known as the action-reaction principle, states that for every action, there is an equal and opposite reaction. This means that if an object A exerts a force on object B will, in response, exert a force of the same magnitude but in the opposite direction on object A. In this image, we see a man pushing against a wall. Here, the man pushes the wall forward. That's the action. The wall pushes the man backward with the same force. Even the wall doesn't move, both forces still exist. They are equal, opposite, and act on two different objects. But this law is also used for rockets or airplanes. The video is now over. I hope you enjoy it and learn something useful. If so, please like, comment, share and subscribe so you don't miss any future videos. Thank you for watching until the end and see you soon.